Welcome back to my course Aspects of Biochemical Engineering. Now, till now I was discussing different aspects of the biochemical engineering, and but today I am going to discuss a very new topic, that is operation of industrial fermenter and the material analysis. Because whatever we have covered up till now, that try to understand how we can analyze the process. Now, this is regarding application of that, because how when we apply it in the fermenter, how the industrial process that is in operation. So this will give you the information that how the industrial fermenter is operated, and how we can do the material analysis. So I hope this particular lecture will be very useful for you. And first, let me start with the schematic diagram of the fermenter. If you look at the fermenter, this is the I told you two type of things, that we have reactor. Am I right? What is the reactor? How you define reactor? Reactor is a vessel in which the reaction takes place. Now, we have in biochemical industry we have bioreactor. What is bioreactor? Bioreactor also same thing, that in the vessel in which the reaction takes place with the help of some biomolecules. That is why we call it bioreactor. So only the difference between the chemical and biochemical bioreactor and chemical reactor is that in the bioreactor mostly we are more concerned about the sterility of the reactor. But in the chemical process, they are not very much careful about the sterility of the reactor. That doesn't play a very important role. So this is the main constant that we have. Now let us see what are the other things that we have. Now here I told you this is the agitator shaft. Am I right? This is called agitator shaft, and I told you this should be perfectly straight. And there in the world, there will be hardly 2-3 companies, they manufacture this the shaft. This should be perfectly straight. Now here the major problem that we have here, this is the connection between the top of the lid and the shaft, because there we put some kind of mechanical seal, what we call mechanical seal, and the mechanical seal is we put in a manner so that no air can enter into the system. That is why because air presents lot of microorganisms. If we allow the air to enter into the system, then contamination will take place. Now there are other lot of things that we have, some this is the impeller. I have already discussed this impeller that is attached with the shaft for the starting purpose, and different height we still have to provide this, because why? To make the mixture perfectly homogeneous in nature. And then another very important thing is the temperature. You have to maintain the temperature. How we for maintaining temperature, two things we shall have to do by passing you can pass the by heating hot water or cold water, through which you can maintain the temperature, because since you are using the starter, if you move the starter at the high velocity, then we can assume the heat transfer will be very good, and the temperature can be maintained. So this is this is the temperature recorder we have, from where we can maintain the temperature. So here this is connected with the controller. So if the temperature rises, the chill water that pipeline that pump will be on, and it will bring the chilled water to reduce the temperature. If temperature is low, then hot water pump will be on, and hot water will be circulated through the jacket. This is jacket. Now one thing I want to tell you, that this kind of jacket is not used by the industry. What do we use in the industry? Because this is the vessel. So what we use, we put some kind of that tubes like this, which the pipe they wrap around the surface of the reactor, so that when you pass the water, then you ensure that water is circulating through the periphery of the this reactor. But when you pass the liquid here, suppose there is some kind of deposition here due to some other reason, so the water will have the channeling effect. If the channeling effect is there, then the temperature control will be a problem. So this is one of the reasons why we use that pipe we wrap around the surface of the reactor. So and for heating sometimes we use the steam, sometimes we use the hot water, and here you can use the sampling purpose. This portion is very interesting. In the lab, how we can do the sampling? In the lab we can do the sampling very easily, because there is a outgoing air outlet. Am I right? In the exhaust, this is the exhaust line. Now here in this exhaust line, if you close this valve, then there will be a pressure here, air pressure here, and due to the air pressure, automatically if you open this valve, then you can draw the sample and collect the sample, and this you can do it very easily. So here we have, you see that this some kind of pH probe is there, is connected here, dissolved oxygen probe that will be connecting here, then air filter is there. Air filter for air sterilization purpose. This is the airflow recorder. We record this flow rate. How we maintain the airflow? By using rotameters, that we can find out what is the flow rate of air. Then this is the Spargel that we have. So you know that, and after the fermentation is over, we draw the sample like this through the harvesting pipeline. Now here I want to point out the different type of valve we use. This is the valve, and the same type of valve is not used for the all purpose. As for example, for harvesting we always use the gate valve. Am I right? And in case of sampling, suppose in the sampling, what we use ball valve. Because why ball valve? Because we can instantaneously open and instantaneously you can close. That is why you can use that. So this is a kind of, this is the pH recorder with the help of pH probe. This is connected with the recorder. You can record that by pH. So this is again connected with acid tank and alkali tank. So as suppose you set a particular pH 7. So if you're neutral, you want to operate. So if the pH increases, then the pump connected with the acid tank, suppose this is acid and this is alkali. So this acid pump connected with this acid, that will be on, and this will take the liquid, that acid in to decrease the temperature. Now decrease the pH. Now if the pH is less, then it is connected with the pump is connected with the alkali tank, that will be on and bring it to increase the pH. So this is how we can control the different operational parameter in the fermenter. Now this is in the laboratory, because how we operate, because I am from IIT Kharagpur. We have bioengineering AG fermenter. This is bioengineering AG. This is the control module. This is called control module. What is the purpose of the control module? Is to he has the different type of controllers we have, and recorders, different type of recorders, different type of controllers we can. So we can monitor that what is going on inside the reactor. That we have different type of sensor here. With the help of sensor and probe, we can monitor. As for example, temperature, we use some kind of thermistor that is connected, and that we find out how much temperature is there. We have pH probe that measures the pH. We have dissolved oxygen probe. We measure the that dissolved oxygen concentration in the fermentation liquid. So these are all plays very important role. So here you can see that different things that we have. We have exhaust air filter, that is one that you can see. This is exhaust air filter. Now question comes, why we put the air filter at the exhaust? The reason is that that when suppose you are running a fermenter, now all of a sudden the power is off, then there is every possibility that air present in the air can enter into the exhaust line and enter into this fermenter. And if you enter into the fermenter, your fermentation will be spoiled. So we want to have exhaust filter. Then we have safety valve, because this is the safety valve that we have, because some other reason if your pressure increases, there is every possibility of some kind of disaster that can be avoided. We have safety jacket, because in the lab this is made of glass. So if it is made of glass, and two type of sterilization technique we have, one is called in situ and the in vitro. So in situ means that the fermenter wherever it is located, here itself we do the sterilization, and we know for sterilization we shall have to maintain the temperature 121 degrees centigrade, and for that we shall have to increase the steam pressure to 15 psi. So to increase so somehow that if the pressure of the steam increases, that may causes some kind of disaster. To avoid that, we put some kind of jacket here. The stainless steel jacket we put across this fermenter, so that even some if your glass vessel burst, it will not affect you very much. Then you have this glass cylinder is the reactor, cooling finger used for cooling purpose, cooling water inlet, cooling water outlet, and turbo stirrer, then starting shaft heating finger to a temperature probe, then hypodermic needle for aseptic temperature, that sampling purpose we can do that. The non-return valve, this is very important, because the non-return valve which is located here, you can see that why the non-return valve is required here. Non-return valve means valve looks like this. So here is like this, it can go one direction, it cannot come other direction, the one direction. So why it is like this? Suppose if there is a power failure, then if the liquid comes out due to some other reason, and then here you have filter, and if your liquid comprises of lot of organic material, if you enter into the filter, then filter will be spoiled, and because it will be contaminated, so your air cannot be sterilized. So to avoid that, we should have this non-return valve or one-way valve, then aeration tube, then air inlet filter, and harvesting valve, and bearing. Bearing is required for any kind of moving shaft. As you know that we required bearing, leakage curb, and motor. But one thing I think it is not mentioned here, that here we use another thing, that is we call that foam controller. We have foam sensor that we insert here, that that as soon as foam formation is there, that is the normal characteristics of the fermentation process, that is touch the foam, then it is connected with a tank of anti-foam oil, and it will take the anti-foam oil and put it in the reactor, so that foam will subside. So this is how the things is operated. Now industrial fermenter looks like that. This is the bigger form of LAC fermentation process. This is the mechanical seal. I was telling you that this is the very important portion through which we can have the contamination. So this should be properly designed. And this is the watching glass. You can say that the big fermenter, we have two watching glass, one this way, another is the other way. One way you can put the light, another way you can see that exactly what is happening in the fermenter. So you can see the anti-foam oil tanker and other things that is located here, different other things that is located here, similar to your lab fermentation process. Now let us give you some information about the different accessories that we have in the fermenters. That first is the fermentation vessel. Am I right? The function of the fermentation is to carry out the appropriate aseptic and predefined environmental conditions. A fermentation vessel is designed in such a way it requires the minimum labor of operation and maintenance. That the volume capacity range from 1 to 2 liters in the lab scale, and 50 to 1000 liter pilot scale and several thousand liters capacity in the industrial scale. So, different capacity that we have required, and main purpose, main thing that we should have to consider that minimal labor operation and maintenance. Particularly, I want to point out that material of construction should be such there should not be any kind of damage to the surface of the material construction, and most of the material is made of stainless steel, and different type of stainless steel, as you know, that is available in the market. One is SS314, one is SS316, one is SS317. The different type of, depending on your requirement, because in fermentation industry we usually go for SS316. Now, material of construction should be flexible and durable, that I told you, non-toxic and to the reactant and product, because whatever in the media, whatever component is there, that should not react with the material of construction. Resistance to chemicals and metabolic products by the organism, resistance to weathering, that low cost and available, it should be available, and easy to fabricate and corrosion proof. As per example, because I told you the stainless steel usually used for as a material of construction. What is stainless steel? Stainless steel is called alloy steel, that is a mixture of metals. So, with iron we mix with different metals, that makes a stainless steel. So, it has been found if the alloy steel stainless steel contain 12% of chromium, it prevents the corrosion. Not only that, if you have, suppose I work with citric acid industry, and citric acid is more corrosive to the material of construction, so we can go for a little bit higher. In that case, we add some kind of molybdenum to have the more acid resistant property of the stainless steel. Now, the nickel that is gives the austenitic structure. Austenitic structure means this is the smoothness of the structure. If the material of construction is not smooth, then what will happen? Your organism may grow on the surface of the reactor, and your process will be hampered. So, that is undesirable. And high transparency, or for photobioreactor, not for all reactor, photobioreactor we require the polycarbonate material we use, because polycarbonate, your transparency will be more high. So, this is how the material of construction we can choose. Now, construction of material differed from the small scale pilot scale and the large scale. And I told you that we have different type of stainless steel, that we have this is 301, 30L, the 316, 316L, and 317 for the small process. And for stainless steel, this is we use this same thing we more or less we use, and mild steel coated with the epoxy material. Epoxy, we know epoxy is kind of it protect the acid and H2S effect that can be we can protect the mild steel from that. Sometimes we use the epoxy coating material with the mild steel. And wood and plastic and concrete of pilot and large scale we use. This is some cases we use mostly as I told you, mostly we prefer the stainless steel material. Now, next that very important that I already discussed, that impellers. This impellers looks like this, and you see that this is called disc. This is disc, and this is the blade. Am I right? And you can remember I told you this number of blades this kind of disc we have at different height, and this we have seen this number of blades plays very important role in the vibration of the fermenter. In the industry we shall have to do the trial error just to optimize the number of blade in the disc. That device is used for the agitation and mixing and create uniform environment in the media. in the media. It leads the suspension of the solid particles, bulk fluid and gas phase mixing. There are various type of impeller, Dix turbine, anchor and marine propeller. I already discussed, so I don't like to repeat it again. Then this is the different type of Spargel, because Spargel just to you have a porous plate type. This is multiple the orifice nozzle and single nozzle type. The different type of 3 different type of aeration that things we required that we put at the bottom of the fermenter. Now baffle I told you you can hear, you can see this is the baffle. Am I right? This is the baffle. And why we use the baffle? To stop the vortex. I mentioned you that suppose you do the hesitation, if you don't use the baffle, it will be like this. Now if you in the reactor, if you have baffles like this and you have a hesitator, then your level is like this. So there should not be any kind of vortex formation, and this is desirable. So this is the purpose why you use the baffle. Now in case of sometimes we in the big fermenter, this we use the hollow type of baffles. Where why we use hollow? Because we use for cooling purpose, because we pass the water through this, because in the since we are in the tropical country, then in the summer temperature of the environment rises to a great extent, so we require more cooling effect. So we use the baffle for cooling purpose. That is why we use. So so this is the metal strip attached with the wall of the fermentation of the baffle. They are used to prevent the vortex, to improve the aeration capacity. They are at 90 degree with the wall of the fermentation vessel. Baffle remains maintain a gap between them, and the vessel wall is enabled to souring this then action, and thus minimizing the microbial growth on the wall of the fermenter. This is how the baffles is why the baffles is we have in this. And other things that we have with the fermentation industry, the compressor. This is to supply air. That this is how the compressor looks. It gives very big noise in the fermentation industry. And then we have rotameter. So it looks like this. And this is rotameter is usually used for low flow rate, a device to measure the flow rate of the fluid through closed tube by allowing the cross section area, and the fluid travels through to vary the causing the measurable effect. Now here we can this is the knob. By opening and closing we can control the flow rate of air. That can be done very easily. This is the rotameter, is easy to handle. This is the air filter that we have. I have already discussed the air sterilization process. We use for air filter we use the fibrous type of material. Particularly we use the glass wool fiber. We use as a for air sterilization purpose. Remove the solid particles, dust, pollen, molds and bacteria from the air. I was talking about non-return valve. Non-return valve is looking like this. It goes one direction. You can see that they have given the direction. The liquid cannot flow this direction. So only it can flow one direction. That is why we call it non-return valve. Then we have reflux cooler, that I told you why the reflux cooler is there. That is also we should understand that why reflux cooler is there, because in the fermenter, suppose this is a fermenter, and now what we are doing, we are sparging air. Am I right? We are passing air in, and this is the thing, and air, this is the air out. Now what is happening when here you are sparging, your air is not saturated, it is unsaturated, but when sparge through this, it will be saturated. So when it takes some kind of moisture from the fermenter. So you will find if you allow the air to go out like this, you will find with respect to time the volume of the liquid volume of the fermenter will keep on decreasing. So what we do, we put a condenser here, so that that whatever the vapor is going down, that should be condensed back to the fermenters. So this is what the exhaust air filter is there. I told you to avoid the contamination, that we can use that. Then we have temperature controller device, we have heaters, we can have heaters, we can have cooler, cool finger, that with different type of arrangement we can have. Then this is the feed and sample port that I showed you with the, if you increase the pressure, air pressure, you can automatically draw the sample again and close the valve. But this is how we can do. So this is the tubes and pipelines and the connected with the nutrition reservoir, and this should be valve is I told you this ball valve is used just to, which can be instantaneously open and instantaneously close. And these tubes or pipelines are used adding nutrients. Sometimes I use for adding the nutrient also, acid and alkali for before and during the fermentation process. Sampling port, sample taken out for analysis, and heat sterilization in situ on ex situ with steam. That is what we use here. Now flow regulation, we have if you look at flow regulation and control, we have safety valve. I told you safety valve located at the top of the fermenter, just to, if you somehow the pressure build up take place, so that before it causes any kind of damage, the safety valve will blow, so that the air will go out like this, so that that the damage can be avoided. We have globe valve, we have butterfly valve, different type of valve with that. Globe valve looks like this. This is mostly used in the water basin. You can see that we slowly you can open, slowly you can close. But butterfly valve can be used for sampling purpose also, along with the ball valve. This you can instantaneously open and instantaneously you can close. Now this is the ball valve that I was talking about. This is used largely for sampling purpose. The assay, when aseptic condition required, can be operated at high temperature. Diaphragm valve also can be used for sampling purpose. Then we have sealing assembly. This is the mechanical seal. I was telling about that this mechanical seal, which is located at the top of the fermenter, that plays very important role, so that air from outside should not enter into the system. That plays very important role. Now packed gland inside this mechanical seal, we have some packing material that is shown here. This is the sap that we have. The several layers of ring made of asbestos are used as a seal to seal the sap. Periodically monitoring and replacement. Only one thing I want to highlight, that if this is a mechanical seal, then in case of biochemical industry, we put some kind of line, so that we can pass the anti-foam oil. And this is sterilized anti-foam oil with the help of pump. We put it inside and just to lubricate the shaft. And if we lubricate the shaft, the friction across the mechanical seal will be less, and since we are passing at the high velocity, so there will be always a positive pressure, and if there is a positive pressure, no air can enter into the system. That is why we use the magnetic drive. Nowadays used to avoid any kind of contamination problem. So this is another recent development we have. Then for monitoring, we required the pH probe. I told you, whenever you use any kind of probe, first you have to calibrate. The pH probe, whenever used, we shall have to calibrate with respect to our standard pH, that is the pH solution. And temperature probe also that is temperature is culture is measured, and this is made of bimetallic. We know that bimetal, it is not like mercury thermometer through which the meter the temperature is a bimetallic. Through the resistance difference in the resistance, we measured the temperature. Now, dissolved oxygen probe, that is also used for measuring the dissolved oxygen. Foam control, I told you, this is the sharp needle that is present at the top of the fermenter, which is just when your foam touch, suppose this is the foam touch here, then it is connected with some your pump is connected with some anti-foam oil tanker, and it will draw the liquid anti-foam oil, and it will take the liquid and put it in the fermenter to subside the foam. That is how the foam control take place. So, this is the different type of this is the summary of the different parts that present in the fermenter. This is the function of the fermenter. I don't like to go in details. Again, I already explained, and this is the different parts that is explained here. So, this is kind of repetition of that. Now, one important thing is the material analysis of the process. That is the first we shall have to prepare the flow diagram. This is the flow diagram of the process. That this is the I have given the examples of the citric acid fermentation process, where cane molasses is used as a raw material, and this is first is stored in the molasses storage tank. Then this is located at the gate of the industry, but the molasses measuring tank are located at the fermentation plant, and then from this you take the desired amount of cane molasses here. Then this contains about the 50% of sugar. We dilute it with the water and with the nutrient, and then we mix thoroughly before it passes through the sterilizer, and then after sterilization we take it in the this is inoculum vessel for preparation of the culture, and this is the production fermenter for production of the media, and this is the air sterilizer. I told you the capacity of the air sterilizer is 10 times higher in production fermenter as compared to the inoculum vessel. And after the fermentation is over, you take the harvesting tank. This is all and it contains the cell mass also. So, first you have to remove the cell mass with the help of rotating disc biology, that rotary vacuum filter. We use RVF. Then we get the solid material cell. We can burn it, and we can get the energy, or and then the liquid material we take it and store it as a filtrate reservoir. Then we pass it through the purification unit for purification of the product. Now, let us see how we can do the analysis of this process. Suppose unaerated fermented field volume in the batch fermentation process is 200 cubic meter, and sugar concentration is 200 gram per liter. Then this 200 gram per liter, so I have already showed you that how you can convert the unit. This I can write that if you want to convert into kg, so what I can write, that how you can convert to kg, that 1 kg is equal to how much? 1000 gram. So, gram will cancel, then you can convert to kg. The liter you can convert to cubic meter. How we can convert to cubic meter? So, cubic meter, 1 cubic meter is how much? 1000 liter. So, liter will cancel. So, 100, 1000 will cancel. That means that 20 gram per liter is equal to 20 kg per cubic meter. You can write like this. So, sugar input we can easily calculate. We know that 200 cubic meters. So, if you multiply that, we will get the 40 metric tons of sugar. Now, carbon, that that every industry, when we work with any kind of industry, that we have two type of analytical devices for finding out the product concentration. One is very fast analyzing device, and another is exact analysis of your product. So, we have seen most of the, if you want to determine the product concentration, exact product concentration, always it take lot of time, particularly for citric acid estimation, it takes more than one day. So, what we do in the industry, that we have a titration method with respect to dilute sodium hydroxide solution by using methyl orange as the indicator. We find out how much sodium hydroxide is required to consume that the sodium hydroxide solution, and that is correlated with total acid yield, and then from that we can find out, and that is why you can see that we have a ratio of citric acid and total acid yield. So, now total acid as 250 degrees centigrade is 14 point, and this 14.82% weight by volume, well, that means 148.2 kg per cubic meter. So, you can easily find out that what is the in terms of metric tons per cubic meter, and also similarly if you know the concentration of citric acid, you can find out in metric tons. So, if you multiply it by 200 cubic meter, you can easily find out how much metric ton of citric acid is produced by your industry. This is how we can do the material analysis in your production parameter. Then as suppose your downtime is 12 hours, and time of fermentation is suppose 140 hours. So, total time will be 140 plus 12 hours, that will be total time. Now, how we can calculate the yield? The metric tons, this is the metric tons of the total acid, and this is the metric tons of sugar yield, sugar that is input in the system. Then we calculate the 74.1%. The conversion efficiency, any kind of industry plays very important role. Similarly, the citric acid available in two different forms, one is CAM, another is citric acid anhydrous. Now, CAM, if we have already seen the CAM concentration is this, and this is the sugar yield, so we can easily find out. So, if you compare the total acid yield and total citric acid yield, always comparatively it will be less as compared to that. Now, question comes that how you can analyze the downstream processing. This is the fermentation broth, then we treat with lime, and then just to precipitate the citric acid in the form of calcium citrate. Then you filter it out, you take out the calcium citrate, then hydrolyze with sulfuric acid, and then it passes through the filtration process, and where the gypsum calcium sulfate will be separated out. Here is the your citric acid, which contain lot of color. We use the activated charcoal to remove the color. Then we again do the filtration to remove the activated charcoal. Then we concentrate with the help of evaporation. Then after evaporation, we cool it down and do the crystallization to separate the crystals, and then we pass it through the centrifugation machine, and finally we dry the sample. After drying, we sieving, but the crystal size will be different, and then we pack it in the polythene bag. This is how we can do that. Now, question come how we can do the material analysis of the process. Now, for citric acid, calcium citrate, citrate formation, how much lime is required. Now, as you know, the lime is produced, this calcium hydroxide is produced from where? Calcium oxide. This is the H2O gives like this. Now, how calcium oxide is formed? From calcium carbonate. If you calcium carbonate, if you heat, it will give calcium oxide and carbon dioxide. So, this is available in the mines. So, this is you can easily calculate that how much if you know the stoichiometry, you can find out how much lime is required, and if you know how much calcium citrate is formed, you can find out how much acid is required, and if you know this how much acid is required, you can also find out how much gypsum is. This is called gypsum. Gypsum is produced, which is a good ingredient for the cement producing industry. So, this is how we can do the material analysis, and this is the two problems I have given here. I hope you can do it by yourself. since time I have little less, so I am just leaving it to you. Just you solve, try to calculate by yourself. I hope you will understand that. Now, so in conclusion, I want to point out that that how I try to give you the glimpse how the fermentation, industrial fermentation processes are operated, and what are the different accessories present in the fermentation process. And our main criteria is to maintain the sterility of the system, so that no contaminants can can enter into the system, and how the temperature, how the pH, how the dissolved oxygen concentration can be monitored, how the sample can be drawn by the fermenter. All these things I try to point out, and finally I try to show you this material analysis with respect to citric acid fermentation process. Thank you very much.